So our lesson for today is about electrostatics. So when we comb our hair on a dry day and bring the comb close to a tiny piece of paper, we note that they are swiftly attracted by the comb. Similar phenomenon occurs if we rub a glass rod or an amber rod with a cloth or with a piece of fur. Why does this happen? What really happens in an electric circuit? Or how does electric motors and generators work? Okay, so the answers to all these questions come from a branch of circuit known as electromagnetism. This is the study of electric and magnetic reaction. So we will begin our study of electromagnetism in this lecture by the electric charge. We will see that it is quantized and obeys a conservation principle. We will study the interactions of electric charges that are at rest, called electrostatic interactions. And these interactions are governed by a simple relationship known as Coulomb's law. This law is more conveniently described by using the concept of electric field. Electric charge, okay, so electric charge is an intrinsic property of protons and electrons, and only two types of charge have been discovered. These are positive and negative. A proton has positive charge, an electron has negative charge. A neutron has no net electric charge. This is shown in this figure. Okay, so the mass of a proton is 1.673 times 10 to the negative 27 kilogram. The mass of neutron is somewhat close enough to a proton, which is 1.675, okay, times 10 negative 27 kilogram. And the mass of that of electron is 9.109 times 10 negative 31 kilogram. So proton has positive charge, neutron no net electric charge, okay, and an electron has a negative charge. So the magnitude of the charge on the proton exactly equals the magnitude of the charge of that of electron. So the proton carries a charge, okay, that is positive, and electron carries a charge of negative. So the SI unit of charge is coulomb. Okay, so let's say that 1 electron will be equal to 1.602 times 10 negative 19 coulomb. Okay, so regarding charge, the following points are worth taking note. So like charges repel each other. So when we say like charges, like for example a positive charge or a proton, say, and another positive charge, okay, they will not be in contact. They will push each other, okay, so they repel. Okay, then unlike charges, okay, attract each other. So let's say an electron or negative charge and a positive charge, okay, they will come to contact or become attractive to each other. Same goes with same charge, okay, like for example negative, okay, and another negative, they also repel. Okay, so charge is a scalar quantity and can be of two types. It's either positive or negative. So charge is quantized, okay, the quantum of charge is electron, okay, and the charge on any body will be some integral multiple of electron, and that is charge Q will be equal to positive, negative, and multiplied by electrons. Okay, so that is N is any whole positive whole number, okay, starting from 1, 2, 3, 4, and so on. Okay, it can never be 1/2, okay, it can never be 1 and 1/2 or 1.5. It should be a whole number, so that is 1, 2, 3, 4, and so on. Okay, so what are the difference between conductors and insulators? So in conductors, electric charges are free to move from one place to another, whereas in insulators, they are tightly bound to their respective atoms. So example of conductors, these are metals, okay? Human body and earth. Earth represents ground, okay? So examples of insulators, okay? Glass, hard rubber, and some of them are plastics. While semiconductors are third class of materials and their electrical properties are somewhere between those of insulators and conductors. Okay, so example of which is silicon and germanium. If you're going to consider conductors, semiconductors, and insulators, these are more on electronics and on the electrical engineering field. Okay, so Coulomb's law. That is the electric force F exerted by one point charge on another acts along the line between charges. So it varies inversely as the square of the distance separating the charges and is proportional to the product of the charges. So the force is repulsive if the charges have the same sign. Okay, so same sign, repel. Okay, and attractive if charges have opposite signs. So formula of the force under Coulomb's law is equivalent to K, which is a proportionality constant called electrostatic force constant, and that value is approximated to 9 times 10 to the 9 Newton meter per coulomb square, okay, or square coulomb. Now, absolute value of the product of the charges, okay? So, Q1 or charge 1 multiplied by charge 2, and that is divided by the square of their distance, okay? And epsilon naught, okay, is permittivity of free space, which is this one, okay? So that is the permittivity of free space, which is equivalent to 8.854 times 10 to the negative 12 coulomb squared per Newton meter square. Okay, so this will be our formula under Coulomb's law, and K is always 9 times 10 to the 9 Newton meter square per coulomb square. Okay, so illustration 10.1. So the question, what is the magnitude and direction of the force on the positive 5 nano coulomb charge in the given figure below? This is based on your PDF lecture. Okay, so from that figure, okay, so magnitude and direction of the force on the positive 5 nano coulomb, okay, on this given. Now you have on the figure the distance between the positive 5 nanocoulomb and the negative 5 nanocoulomb is 3 centimeters, right? Okay, and then the distance of the negative 5 nanocoulomb and the 10 nanocoulomb is 4 centimeters. Okay, so our solution for that, so our concept and principles. So the electric force exerted by one point charge on another acts along the line between charges, and the formula E of Coulomb's law is given. Okay, so I'll just draw the figure. Okay, this is just a representation of this figure. Okay, so I assume that charge 1 is the positive 5 nanocoulomb. Okay, and charge 2, Q2, will be equal to negative 5 nanocoulomb, and the charge 3 is 10 nanocoulomb. Okay, these are simply, okay, representation. Okay, you could say this is Q3, this is Q1, and that is Q2, or you can say Q1, Q2, Q3. Okay, it's your choice, but then I have assumed this is charge 1, charge 2, and that is charge 3. Okay, so okay, so we need distance between each charges. So let's say Q1 and Q2 has a distance of 3 centimeters. Okay, and Q2 and Q3 has a distance of 4 centimeters. But then on the figure, okay, Q1 or 5 nanocoulomb and 10 nanocoulomb, okay, based on the figure, it doesn't have its given distance. Okay, so I have placed R13, that is the distance between charge 1 and charge 3. Okay, now given, okay, so based on the definition or the notes that we have, similar, okay, or same sign repel, right? That is positive and positive charge. Okay, okay, so they repel each other. Okay, so tendency, there's another force here that is bounded by this straight line, okay, along the line between charges. So this is the line. Okay, okay, now if that is the force acting on charge 1 by charge 3, okay, so I denoted F3 on 1, so that is acting on charge 1 from charge 3. Okay, now I have placed another, okay, force, which is force acting on charge 1 by charge 2. So I denoted F2 on 1. So charge 2 on 1. Okay, so they have this different sign, okay, or opposite sign, so they would attract each other. Okay, so the force acting on the charge 1 will be attracted to charge 2. Okay, now given, okay, so solving for distance between charge 1 and charge 2 by Pythagorean theorem, right? This is a right triangle. Okay, so that becomes the hypotenuse. So distance between charge 1 and charge 2 will be the square root of 3 squared, which is this one, plus 4 squared, okay, will be 5 centimeters. Then that value will be converted to meter, so that is multiplied by 1 meter per 100 centimeters. The unit centimeter will be eliminated, and that has a value of 0.05 meters. Okay, same procedure, okay, converting our distance charge 1 from charge 1 to charge 2, which is 3 centimeters. Okay, so centimeters and centimeters will be eliminated, and that gives you 0.03 meter. Okay, same goes with distance between 2 and 3. Okay, I have converted them all. Okay, centimeters will be eliminated, so the value is 0.04 meters. So take note that the distance between the two charges, okay, is always in meters. Now applying Coulomb's law, okay, so let's say force acting on 1 by charge 2, which is equivalent to K, Q1, Q2 R squared, right? So that is charge 1 and charge 2, okay, Q1, Q2, and the distance between them is R12, okay, but then it is square, so square of the distance. Substituting the values, The proportionality constant is 9 times 10 to the 9 Newton meter square per column square. Okay, this is K. And then charge of Q1, okay, absolute value 5 times 10 to the 9 column, right? Nano is times 10 to the negative 9, okay? And then charge 2 is negative 5, okay? Negative 5 times 10, negative 9, okay? So the product of this will give us 25, right? Then positive because of its absolute value. And the distance between them is not in centimeters but then in meters. Okay, now by checking the unit, if this will be squared, okay, this becomes meter squared below, and on the top meter squared, so this will be eliminated. Column multiplied by column is column squared, right? So column squared here, column squared here will be eliminated, so the unit left is Newton. Okay, so simplifying using your calculator, we'll have an answer of 2.5 times 10 negative 4 newtons. Okay, so the force on charge 1 by charge 2 is 2.5 times 10 negative 4 newtons. So similar procedure, okay, we will be solving for force on 1 or charge 1 by charge 3, which is this one. Okay, because the problem on this stating force on the 5 nanocoulomb. Okay, so we will not compute the force between these two charges, Q2 and Q3. Okay, we are only referring to this charge. So charge 2 and charge 1, and charge 3 charge 1. Okay, I have erased all the ink that I have placed. Okay, so continuing, so similar procedure using Coulomb's law. So that is F3 on 1. So that is the force on charge 1 by charge 3. So this is, oops, I forgot to remove 2 here. Okay, so this is F3 on 1. Okay, that is K, Q1, and Q3. So we are referring on charge 1 and charge 3. So that is Q1, Q3. And the distance between charge 1 and charge 3, which is this one. Okay, substituting the values, so that is K is proportionality constant, which is equivalent to 9 times 10 to the 9 Newton meter square, column square. Okay, then Q1 is positive 5 times 10 to the 9 column or nanocoulomb, and Q3 is 10, which is this one. Okay, times 10 to the negative 9 nanocoulomb, and that is divided by 0. Oops, the distance between them is R13, which should be 0.5. So perhaps I forgot to change this value. Okay, okay, so this is 0.05 meter then squared. Okay, so using the calculator, I'll just double check if 1.8 times 10 negative 4 is correct. Okay, if this value is correct. Okay, I'll just recompute using the calculator. So that is 9 times 10 to the 9, then multiply by positive 5, then negative 9. Okay, and then 10, then negative 9, then divide it by square of 0.05. Okay, then it should be 1.8, okay, times 10 negative 4 newton. So this is the force on charge 1 by charge 3. Okay, now the question is, what is the magnitude and direction of the force on the positive 5 nanocoulomb? Okay, continuation. So we have computed, okay, 2.5 times 10 negative 4 for F2 on 1, and F3 on 1 is 1.8. Okay, now upon solving for it, the force, the magnitude, okay, we will be using the component method. So we will be first determining the x components and y components of these forces. Okay, individual x and y component, but then we need angle. So let us compute angle theta here. Okay, so angle theta. So angle of F2 on 1 is along the horizontal, so this is 0 degrees. Okay, x component, okay, then y component probably 0. Okay, then for this value we need angle theta. So computing for angle theta using the formula of arctan, then y all over x. So this is computed by y, which is opposite side, which is 4, and then 3, or you can use 0.04, and this is 0.03 based on distance given earlier, right? But then the angle will be 53.13 degrees. Okay, so solving for the x and y components, let's say on F2 on 1. So F2 on 1, x component will be still 2.5 times 10 to the negative 4 newtons because of the formula. Okay, so Fx will be equal to F, we call this formula, okay, cosine theta. Theta for this force is 0, so that is 2.5 times 10 negative 4 for F, and cosine 0. Cosine 0 is 1, so that remains the same. But then for F2 y, for the y component, so for y component, that is F, then sine theta. Okay, sine 0 is 0, so 0 multiplied by value, that leads us to 0. Okay, so I'll just erase. And now for F3 on 1, okay, so that is F cosine theta. Okay, 233 degrees, but then my theta here is 53.13. So I have counted the angle from the positive x-axis going to that force. Okay, so this is theta plus 180 degrees, right? 180 degrees. So that will give us this value. So 1.8 times 10 negative 4 cosine will give us negative 1.08 times 10 negative 4. That negative is the direction of this x component, that is to the left, right? So the value is negative 1.08 times 10 negative 4 Newton. And for the y component, simply cosine becomes sine. Okay, so 1.8 times 10 negative 4 sine 233.13 degrees. That gives us a negative 1.44 times 10 negative 4. So negative is going down, okay, for this value. Now, summation of forces along x, or the x component. So all x component, this one and this one. Okay, so 2.5 plus negative 1.8. So that gives us 0.7 times 10 negative 4 Newton. Same goes with summation of forces along y. So that is 0. That is negative 1.44. So 0 minus negative 1 minus 1.44. So that is 1.44 times 10 the negative 4 newtons. Now, the computed values are as follows. Okay, this one. Now, the resultant force, or the magnitude of the force, will be this formula. Okay, summation of forces along x squared plus summation of forces along y squared, taking the square root. Okay, so substituting the values will give us 0.7 times 10 negative 4, then square, okay, for summation of x, and for summation of y, that's negative 1.44 times 10 negative 4 squared. Okay, and simplifying this equation, that will give us a magnitude of 1.6 times 10 negative 4 newtons. Okay, now the direction, okay, using the formula, okay, solving for the angle. So that is from this formula, that is tangent theta will be equal to y all over x. Okay, summation of forces y will be y, and then x will be summation of forces along x. So that is y is negative 1.44 shown here. Okay, then 0.7 positive, okay, times 10 negative 4 newtons, and that will give us a value of negative 64.07. Now double checking the angle, okay, negative 64.07 based on the x and y values, based on these values. Okay, so if you're going to plot these values using the Cartesian plane, summation of forces x is on this side. Okay, this is summation of fy approximately, and summation of fy is this one. So tendency, the resultant force will be on this side, on this quadrant, and the angle is negative 64.07. So this is also correct, but then we are taking the direction from the positive x axis. Okay, so when it comes to angle, okay, reminder, this will be the angle to be considered. Okay, so I have added 360 degrees to this value to get this 295.93 degrees. So therefore, the magnitude of the force on the 5 Newton nanocoulomb charge is 1.6 times 10 negative 4 newtons, and the direction of the force is 295.93 degrees from the positive x-axis. Okay. Illustration 10.3. So I have skipped illustration 10.2 because that problem is similar to illustration 10.1. That is illustration 10.2 will be added to your activity of the day. Okay, so three charges for illustration 10.3. There are three charges are arranged as shown in the figure below, okay, based on your PDF lecture. So find the magnitude and direction of the electrostatic force on the 6 nanocoulomb charge. So you should be familiar with nano, micro, milli, pico, and so on. Okay, so that is times 10 to the negative 3, negative 6, negative 9 for nano, negative 12, negative 15, and so on. Okay, so based on the figure, you have 3 nanocoulomb and there's no sign, so this is a positive charge. Okay, then right at the bottom there is a 2 nanocoulomb with no sign, so assume this is positive. Okay, and this is a 6 nanocoulomb which is also a positive charge, so all of them are positive charges. So the distances are given. Okay, distance of 3 up to the midpoint is 0.5, then 2 nanocoulomb up to the midpoint is 0.5 again, and from this midpoint up to the 6 nanocoulomb charge is also 0.5 meters. Okay, so all distances are in meters. Okay, now same concept using Coulomb's law. Okay, So the electric force exerted by one point charge on another acts along the straight line between charges. So the formula is given. Okay. Now I'll just redraw that given figure. Okay. So I have assumed Q1 is 3 nanocoulomb, Q2 is 2 nanocoulomb, and Q3 is the 6 nanocoulomb, which is this one. Okay. Distances 0.5, 0.5, and 0.5, similar to the figure itself. Okay. Now, since we are finding the magnitude and direction of the electrostatic force on the 6 nanocoulomb, so we need the distance between charge 1 and charge 3. I have denoted it as R13. Okay, solving for that by Pythagorean theorem. So this is a right triangle figure, right? Okay, so that is 0.5 square plus 0.5 square, then square root, then this will be the value of its distance. Okay, so now we need also the distance between charge 2 and charge 3. Okay, I will denote that as R23, and solving for that distance, okay, similar value. Okay, now what else? What do we need? Okay, forces. So the forces on charge 3, the force on charge 3 by charge 2. Okay, so acts along this straight line. So positive, positive, so they repel. Okay, so similarly, there's also force here, which is equivalent to the magnitude of this force, but differs in direction. Okay, so similarly, force on charge 3 by charge 1, okay, positive and then positive, so they repel. So there's also another force on this side. Okay, this force and this force are equal in magnitude, but they differ in direction. Okay, so now, so we apply Coulomb's law to solve for this force and that force. Okay, similar from the given previous example. Okay, so the force on charge 3 by charge 1 is Q1, Q3. So Q1 and Q3 by this value. Okay, then that distance is R13. Okay, substituting the values, this is the proportionality constant, 9 times 10 to the 9. Charge 1 is 3 nanocoulomb. Okay, charge 3 is 6 nanocoulomb, and they are positive. Okay, and the distance between them is 0.0707. Okay, now simplifying that, you'll have 3.24 times 10 negative 7 Newton. Okay, similar procedure to solve for the force on charge 3 by charge 2. Okay, so that is K, Q2, and Q3, then R23, then squared. Okay, substituting the values, 9 times 10 to the 9, then Q2 is 2 nanocoulomb. Okay, and charge 3 is 6 nanocoulomb, and the distance between them is 0.707, that's squared, and the value of the force on 3 by charge 2 is 2.16 times 10 negative 7 newtons. Okay, now these are the forces now. Okay, now we will be solving for the x and y components of these values. Okay, let us consider F1 on 3. So F1 on 3 right here. Okay, F1 on 3, and this is F2, okay, on 3. Okay, F1 on 3, x component, it is under quadrant 4, so positive x, negative y, so that should be our value. Then for F2 on 3, positive x, under quadrant 1 positive x, positive y. Okay, now solving for the angle theta. Okay, so I have used this angle. Okay, since they have the same value. Okay, probably this is also angle theta, and also this is also angle theta. Okay, they are symmetrical in distances, so I can say that this is theta and that is also theta. Okay, so let's say f1 for the angle, so that is 0.5, 0.5, this one and that one. Okay, opposite all over adjacent, that will give us 45 degree. So solving for the x and y components, so for f1 on 3, this one. Okay, so if this is also theta but then this is negative, I will consider this angle up to that point. Okay, so that becomes 360 minus 45 degrees, and my angle will be 315 degrees, right? So that will give us f1 on 3, then cosine theta, but then our theta is 315 degrees. Okay, so 3.24 f1 on 3 cosine 315. Okay, so the value of the x component of f1 on 3 is positive. Okay, this value. Then for y component, oops, this is sine theta. Now f1 on 3 is 3.24 times 10 negative 7 newtons, then sine 315, then that gives you a negative 2.29 times 10 negative 7. Okay, so negative directed downward, so here it is. Okay, now for f2 on 3, okay, so same formula, f2 on 3, so this is f2 on 3. Okay, so f2 is 2.16 times 10 negative 7, which is this one, then cosine 45. As you can see, this is only on quadrant 1, right? So this is the value of theta, so I have used 45 degrees, so the value is positive 1.53 times 10 negative 7 Newton, and it lies on the positive x axis here. Okay, then for y, okay, so this is f2. Oops, I forgot to change this to sine. Okay, so same, so 2.16 times 10 negative 7 sine 45 degrees will be equal to 1.53 times 10 negative 7, and that's positive directed upward here. Okay, this one. So x and y components are already solved. Now we will determine the magnitude, or the summation, the magnitude of the force by means of summation of forces of x and summation of forces along y. So summation of forces of x, so this is x, okay, f1 on 3x, and this value, so 2.29 times 10 negative 7 plus 1.53 times 10 negative 7, that gives us 3.82 times 10 negative 7. Okay, so summation of forces y, so this is negative 2.29 plus positive 1.53, and that gives us 0.76, negative 0.76 times 10 negative 7 newtons. Okay, so solving for the magnitude, since the summation of forces of x and y are solved. Okay, solving the magnitude of force on the positive 6 nanocoulomb charge using this formula. Okay, so summation of forces x squared plus summation of forces y squared. So substituting those values, so this one, that one, will give us this one. So 3.82 times 10 negative 7 squared, then plus negative 0.76 times 10 negative 7, then square root of that full value will give us 3.89 times 10 negative 7 Newton. So this will be the magnitude of the force. Okay, now solving for its direction. Okay, direction of the electrostatic force. So that will give us arctan of y, summation of forces y, all over summation of forces x. So negative 0.76 for y and 3.82 positive for x. Okay, then simplifying, you'll get an answer of negative 11.25. Okay, so this is also correct because as you can see, okay, if I draw this figure, then the x and y component will be positive x. So I'll have a positive x here, okay, and a negative y. So the resultant force lies on quadrant 4, and that negative 11.25 will be this angle. But then we are still considering the what angle from the positive x-axis to that force. Okay, so we will be adding 360 degrees to this value so that you'll get the 348.75 degrees from the positive x-axis. So therefore the magnitude of the force on the on the 6 nanocoulombs is 3.89. Okay, 3.89 times 10 negative 7 newtons, and the direction of the force is 348.75 degrees from the positive x-axis. Okay,